forecast of the second period will get impacted, and that in turn will have a cascading effect on all the forecast, because the forecast of the first period is influencing the second, third, and so on. I got the question correctly.
So suppose if you want to shuffle, right? If you want to shuffle the numbers, so in that case, what is the impact and how that impact will be evaluated? Means, what is the parameter? What is the metric we should actually think about?
In terms of metric, it could be a difference between the actuals and the forecast, and that could be calculated as W map or map. So that difference could tell us whether it's a correct thing to do or not.
Correct. Right. So we will be able to understand whether this model is working well or not based upon the forecasting error.
So, Krish, I had one question, that just popped up in my mind. So, in the first case, we're using the most vanilla version of the cross-terms formula. So, here we are using the average. In the next case, we are using the intercept formula. Are these two things linked, like the version of the cross-terms formula that we're using and the first value, or the first value could be selected independently of the formula that we're using?
Yeah, independently we can select. There is in the case of Crosstown model. In the case of Crosstown model, we have there is nothing defined in the literature that what should be the first value. So we have the leverage. We can leverage the first value. So how so which all depends upon, because the first value will impact the overall forecast, right? The first value is going to impact the overall forecast. So what we have to do is that we have to carefully choose our first value. So in case if you choose a first value and our accuracies are not very high, so what we can do, we can change our first value, because the first value is going to impact the overall forecast. So that is one of the levers. The first value of the first forecast value is one of the levers, because this impacts our forecasting accuracy. Have you got the understanding, Swapna, what we are trying to discuss?
Yes, Krish, I'm trying to understand.
See, this is all you get once you forecast. Once you practice. Unless you practice,
yes,
it's very difficult to understand this. This all methods. So it is very important that you take the Excel sheet and take the data and start practicing them. Then only you will be able to understand. These are very very important informations which are uh, which are not discussed on public platforms, because these are the levers has to be which has to be worked. Now we have to modify. This is the first part, because the last time we discussed that this is the first part of our forecasting for the intermittent, and we have three different approaches to start with. So like this in the the first approach. And so if you look at the third approach, forecast 3, we have taken the median, right? So median is coming as 0. So if you see the median as 0, then I think it's better to take something else other than median, because if you go with even though the model is very strong, even the third approach may be very strong, but since our first forecast itself is not giving us right intuitive value, right? This may be the statistical value, but it's not giving the right intuitive value. if it is not giving the right intuitive value, then I think it is imperative to change our statistical value, because the forecast 3, it is an average of the two sales, right, and divided by the time period, right? That's called rate of sales. If you remember, the first during the first TSB, we did the rate of sales. Remember, Ananya, we took the average and we took the
Yes.
so that is what that is what the approach we are using in the forecast 3. So if you look at the alpha into, if you just go to second cell, what is the alpha? Alpha is G3 into average of the two period sales value divided by the time difference of two sales value. So this is rate of sales, which we have done in the first model. Before coming to the cross term, we did the first model, right? So there we have done the rate of sales. So we are using here the rate of sales as our first element of the first part where we are doing the smoothing or dampening. This is a very important model. So if suppose we are getting 0 there, instead of 0, we can actually take some other value. Let's say we take the max. Why we take max? Or why we take min? Suppose if we think the product is having a very good sales, it's good to go with the max of the overall sales. Or we can go with the, suppose if we have a service level of 95% or service level of 98%. Right? If you have a service level of 95%, we can go with the first value as a 95 percentile. So let's choose the first value as 95th percentile. The first value.
All right.
So how do we do that? Yes. Inclusive. We will include a first value also.
Okay. So if 5 to given it the value, then if 4 to F28, the value has been given percentile minus 25. Okay, to get the percentage sign. So this is the value that's coming in.
Yeah, so this is 18.85. So we can, if you want, suppose we put 18.85. So what we're trying to train the system. We're trying to train the supply chain, or we are trying to train the warehouse to go with the highest means highest inventory, right? Highest possible inventory, which has a 95% service level. We're going to start with the highest inventory, which is highest inventory means a inventory which can serve 95% service level. That's the first one. And rest everything will be same. Either you can use either of the three models. So suppose you want to use second model, you can use second model. You want to use third model, you can use third model. I think you have to rewrite because it will change the cells.
Yes.
Or you can copy and paste here. Copy only the formula, not the excluding the equal to sign. Just copy the text from the formula.
Okay.
Just don't take equal to sign. So here, if you look at here, F5 minus F6 is fine. E6 minus E5 is fine. Okay. And why we're getting 0 here? We should not get. I think this is what.
I think it disturbed the formula here.
Only
So
take the
just
text.
do Control
Just
C.
take text. Just take the text. Just take the text and paste here, and we'll put the equal to sign later on.
Okay.
I think we should not remove the formula from the. Okay, that formula is there already. Okay. Now put equal to sign here. Okay, now here what you do, you have to change one change, make one change. J instead of J, okay, this is J5. Okay, J5 is fine, H3 is fine, HG3 is fine. Now average of GE. No, we don't want average of JE, we want average of F5, F6. And this is F5 and F6, and this F6 minus F6 minus not is it's not F6 minus F5. I think it is uh, E6 minus E5. Now I think it's fine. So if you look at here we are training the system. We are training the supply chain system to start with the 95 percentile inventory. And this model, this approach should only be used when we expect the product or a part will have high demand or will start with high demand. The actual term will be the product or a part if it has a potential to start with very high demand. Product or part or service which has a potential to start with very high demand. Then only this approach should be used. And why we should use this approach and in this particular scenario? Swapna, can you comment? Why we need to start? Why we need to start with 95 percentile if the product has a potential to start with very high demand?
Because in forecast 3 here we are getting 0. So that would impact the overall forecast. So that's the reason here you have taken with 95% level. Is that correct, Krish?
Think. But if it is
I think he dropped off.
Hello.
Hi, Krish. Yes.
Yes, Krish.
Yeah, just this if you have a 0 in the forecast 3 there, there is no correlation with the forecast 4 model. There is no relationship there.
Right. Then why you have taken 95% service level, Krish, for the forecast 4?
Okay. Suppose you have suppose you have two products, and for example, there is a marriage. Suppose you have there is a marriage season going on. For example, in India right now, there is a marriage season is going on. You have a kirana shop. Okay, you have a kirana shop. Let's say retail shop, and you retail shop for the daily use products, and there is a marriage season is going on in India. And in the marriage season, what is mostly sold? Suppose if you're selling rice in the non-marriage season, where the marriage season is not very high, you're going to sell in an average. You're going to sell 20 kgs per day, for example, 20 kg per day in a non-marriage season. But in a marriage season, it could go to 100 kg per day, right?
Okay.
So for that you need to prepare. For that you need to prepare. Now the season is for the marriage, and in India, every marriages people will serve rice to their guest. Rice
Yes.
or basmati rice or normal rice. So they will serve every host will serve rice to their guest. So in a marriage season, you need to stock more as compared to the non-marriage season.
Yes.
So when you know that there will be huge demand, and suppose you have data for the non-marriage season, if you look at column F for fan, where we have a sales data.
Yes.
Let's say this data belongs to non-marriage season data. this data which has been given to you for forecast, this belongs to a non-marriage season data.
Okay.
Now, with this data, you have to forecast for the marriage season data. With this forecast, which you have in the column F, you have to use that data to forecast for the marriage season data. So what you will do, you will start at least with whatever you sold. What the approach which you are taking right now here is that whatever I have sold in the non-marriage season data, okay, I will pick a sales which has 95th percentile. I'll pick a sales value which has a 95th percentile. So 95% of the data or 95% of the sales will be less than the value which I picked in the non-marriage season data. That is the approach I'm going with.
Okay. Why 95% then?
Why 95%? So at least we will be ready. At least we will be ready with a sales or inventory. At least we will be ready with an inventory, right? Which will service 95% of the sales orders. That's what the definition of percentile. Suppose
Yes.
if you choose an inventory value, like if we have chosen 18.85. If you look at column J, the first value is 18.85. That is our 95th percentile value. What is the meaning of this? If you say 90, so this value 18.85 can serve 95% of the sales orders at any given point. Suppose if you get an order of 18, if you get an order of 18, are you in a situation to serve the customer? If you get an order of 18, are you in a position to serve the customer? If you get an order of 18 and if you have an inventory of 18.85, if you have an inventory of 18.85, if you get a sales order of 18, will you be able to give the order to customer? You have inventory, yeah? You have an inventory, right? You have a retail shop and you have an inventory of 19 units. 18.85 means 19. 18.85 means 19. 19, you have suppose 19 kg of rice. You have 19 kg of rice. You get an order of 18 kg of rice. So will you be able to deliver the product will you be able to deliver 18 kg of rice to customer? Yes or no? You have 19 kg of rice in the stock and you get an order of 18 kg. So will you be able to deliver 18 kg to customer? It's a very simple question.
We have order of 19 kgs.
No,
but we have
not an order of
kgs,
19
so 1
kg.
kg we cannot able to deliver.
You have a stock of 19 kg.
Okay.
And you have an order of 18 kg.
Okay. Then we can deliver.
If you have a stock of 19 kg, you have an order of 17 kg. Will you be able to deliver?
Yes.
If you have an order of 16 kg and you have a stock of 19 kg, will you be able to deliver?
Okay. Yes.
So that is why we are keeping a 19 kg here, because we believe that 95% of the times, you get an order will be less than equal to 19 units, 19 kg.
Okay.
We believe that 95% of the times we'll get an order less than 19 kg based upon the non-marriage season sales of column F. That's why we are choosing 95 percentile. If I say 98% of the times you should be able to deliver the order within given inventory. If I say 98% of the times you should be able to deliver to customers with a given inventory. In that case, what should be the percentile?
It should be 98%.
Not 98%. It should be 98 percentile.
Percentile.
There's a difference between percent and percentile. We have already studied those things.
Yes, yes.
So, in that case, in that case, my percentile will change to 98 percentile. What is the formula? Ananya, can you just type the 98? Can you derive 98 percentile? In that case,
So can I change this to 98?
98. So now it is 90. So the year doesn't make difference. If you rate 95 or 98, it doesn't make difference. Because if you take 95 percentile also, it is 18.89 is equal to 19 only. 18.89 is 19. So 98 percentile is also going 19. So if you go 95 or 98, in this case, it will not make difference. But it will make difference in overall. But law of diminishing returns will be applied. So that is a different case. We'll see it later on. So what I am doing here is that I don't have the visibility of how much sales will happen in the marriage season. So what I'm taking is I'm taking one of the highest sales which happened in the non-marriage season. I'm starting with that particular value for the forecast. And the first forecast, especially in the single exponential smoothing, we are applying in the Crosstown model here. The single exponential smoothing we are applying in the Crosstown model. Of course, this is the first part of the Crosstown model. So we are applying that. So in the single exponential smoothing, always remember your first forecast will be a lever of your accuracy of the forecast. So you have to play with the first forecast using different kind of approaches. So we have taken one approach in a statistical manner. We have taken three approaches in a statistical manner. We took the average, we took the median, we took the intercept. And the fourth approach we're taking in the business way. But of course, this is also in a statistical way, but we're taking in a business approach. We're bringing some intuitive approach. Right? We're bringing some intuitive approach in the fourth case because we think the zero is not a right way to, zero is not the way we have to go with the forecast. Are you getting a point? Why we have chosen this 19 or 18 or 98 percentile or 95 percentile? So like this, you have to use several kind of judgments based on your business scenarios or business problems you're going to encounter while doing the forecast. So forecasting is just not like you use a template and generate the forecast value. Forecasting is not at all most that way. You have to use plenty. You have to understand the business problems. You have to understand the scenarios. After understanding the scenarios and the problems, you have to come with your approaches. You have to make the modifications. If you just deploy a forecasting formula itself, you might not achieve the right results. That's one of the biggest problems in the industry, that people are either dependent upon the statistical tools or on Excel templates without applying any kind of rationals. So that is what the biggest problem is. So in that case, you cannot blame a software tool. You cannot blame an Excel template. You cannot blame that. Those tools or those templates are derived for a specific problem, not for all the problems at once. So the ability of the forecaster is to understand the problems, and based upon the problems, you should be able to make modifications on regular basis. It's not one and for all. It's not like if I create a forecast and it will be applicable for the entire year. It's not like that. You have to keep on understanding the scenarios, keep on understanding the challenges. Based upon that, you have to keep on making the modifications on the forecast templates, and then you will be able to create the right inventory solution for your company based upon the make to stock strategy. Okay, so now this is the first piece of the or first part of the Crosstown model. Now second part of the Crosstown model, now we'll Now we'll take the second piece of the forecasting model.
Sir, just one point. So Croston's model is the same as single exponential method.
No. This is the first part. Second part we will come. We will work.
Okay, so the second part is not the same as
Yeah.
single exponential.
Yes.
Okay.
Yes. Yes. Now let's work on second part. The second part, what we will do, we'll make some modifications here. Now in the second part, we can go with two different approaches. Okay. Now let's go to column L and let's do the second part of the model. So I hope so, Swapna, it is clear for you what we are doing here. Yeah, remove the data points from there from the column M. Okay. Now, if the two approaches we will go with first approach, and second part first approach. Okay, second part first approach. The second part first approach, we will either, if suppose second part first approach, you can just mention there.
Okay.
Before that, can we make a plot between sales and forecast 1, sales and forecast 2, and sales and forecast 3, sales and forecast 4, right? Just choose all together and make a line chart. Line chart. Okay, so here our blue one is what? Blue one is our sales, right?
Blue one is the same.
Forecast one is our orange. Forecast one is. Can you choose the I think we have to distinguish our colors, not actually.
Not change. This is the sales. The sales is like this.
Yeah. Go to format on the top. On the top, you see format. Yeah, click on the sales graph there below. The sales graph. Yeah, click on that. We are selecting only one point there. Now don't select only point. Click on any intermediate. Yeah, click on that.
Yeah.
Still, we are selecting one single points there.
Yeah.
Come out of
just trying to click on different parts, but it is just picking
just
up one point.
just come out of this chart. Click on outside the chart. Now click on the blue.
Okay.
Now click on the blue. No, don't clicking on the chart actually. Yeah, yeah. Now it's fine. So now go to format and select any one distinguishable color. Yes. So this is a.
So now if I'm selecting a color that would easily attract the attention and different from the other colors like red, it's not picking up.
Not picking up. So click on that sales on the bottom. You see the label. Go to labels at the bottom. I think legends at the bottom. Click on the sales. Yeah. Now go and choose the color. Solid fill or solid fill. Yeah. Click on solid fill.
So if I'm clicking on solid fill, it's automatically going down to automatic.
Okay, then go to I think that's not the color actually we have. Okay, you just choose the color from there. Choose the color from there, the bottom.
Okay.
Make it red. It should change.
Again, going back to, it's not allowing for some reason.
Other way, go to format on the top then.
Okay, format on top.
And go to shape fill red or anything. Should change, I think.
Okay, let's now take this red. Okay,
I think
now
it's
I
changed.
think it's working.
Okay, now you choose that orange and the two oranges are there, no? The two oranges are there. One orange and one dark orange, one light orange. So choose one of them.
I selected the orange, right? Yeah.
You can select for the legend also. You can select legend. It will happen. So I select the legend, one of the legends. At the bottom, you see legends are there.
Okay.
Yeah, select one of the legend, whichever one you want. Forecast 1 or forecast 3. Forecast 1, because we have to change the forecast 1 or forecast 3. One of them we have to change. Yeah.
Okay.
Then
So
go to
pick
format.
this
Yeah,
one.
shape, fill, and then choose some dark. Yeah. Then come out of that. Come out of that.
Okay.
Come out of the chart. I think we should change.
Should I change now and see what happens? Once it happened, now okay, it's the outline. It's okay, not the shape. It's the outline. Okay. Any other color that I can change?
Yeah,
Maybe this
forecast
one
between
or
forecast 1 and
anything about
forecast 3.
this outline.
Between forecast 1
So
and
I can
forecast 3. Yeah, fine. So now we have forecast 1. Okay, the forecast 4 is the blue one, right?
yes. So it starts with a very high service level and then comes down.
Yeah. So if it is like a forecast 4, if you look at your forecast 4, it is all, it is looking most suitable in the beginning because it is matching. It could match the first, but if you look at, nothing is going above. If you look at, there are two peaks, there are three peaks are here in the sales. The first peak is at period number 3, second peak is at period number 8, and third peak is at period number 18. The sales layer, the red one, right?
Yes.
So there are three peaks are there, right? So what we are seeing, the three peaks, it is the first and second peak, and there is a third peak. The first and second peaks are almost close to, they are close to each other. Third peak, it is not close.
Right.
Right. Fourth peak is, it is again matching. The fourth peak is also there at period number 22. At period 22, the fourth peak is also there and it is matching. So what we do, we need to do also see that we have to also map a cumulative graph for all the four with the sales. So let's build one cumulative data values, and then let's build one more chart with the cumulative values. So we'll see how close they're coming to each other.
All right.
You can plot at the bottom, somewhere. No, don't mix the cumulative with this. Plot the second table at the bottom of the chart.
So can you repeat the requirement? So I'll be
Yeah. So
plotting the cumulative sales of the cumulative value of each one of the forecasts.
yes,
That
cumulative.
was the ask, right?
Yes, and then we'll build line chart for the only cumulative.
All right.
Remember, the first.
This is 19, right? Yeah, this was 19. At 7, it should become 23. Let's see. I think it is correct. If I drag this is G5. Yes, I think this is 19, right? Yeah, it should be
No,
fine.
let's do like
Or
this.
just
No, don't like this. Don't do like this. Yeah, this is
okay.
cumulative. It's not cumulative, right?
Yes, so this is so
Let's do one thing. Let's take the
okay.
let's take the first value as first value from the top. On the for the
Yes,
sale,
that's
from
what.
the sales Yeah.
Okay.
Now second value, click on equal to.
It's already giving the cumulative here.
Okay, okay, no problem. Then it's fine.
I need to make a change. So this should be G5. Just do the sum. So I want this to be H5.
So, Sapna, why are you building this cumulative graph?
So H5. At any point of time, this was 3.91 and this was 4.81. Okay, if I add the first two, but value is 4.81, so this is correct only. Is it? Let's at the top three, it should give the 6.19. 6.19, okay. This top B, they should give me 31.69, 31.69. Yeah. So I think the formula is correct. So now, okay, sum of this cumulative.
So let's build a chart for all the four forecast and sales.
Okay.
Ananya, why are you doing this cumulative?
Okay, so because wanted to compare the total sum of the forecast along with the total sum of the sales. That way we can take into consideration any back orders or any advance inventory that we might be holding. That is my understanding.
Yeah, okay, thank you. Krish, can you explain this, Krish?
Yeah,
Why
we'll compare.
cumulative?
We'll compare the two graphs, then we'll get the understanding. So
Okay.
let's build this graph, then we'll.
Uh,
Last discussion also we have in the last session also we have discussed the same thing. So why we need to understand the cumulative. Why we need to build the cumulative forecast. Cumulative forecast is always understand whether forecast is mapping the sales period wise, total sales period wise. We'll compare the two graphs and then we'll understand. So give the same color formatting, the same color formatting which we had on the top. For sales we have red. Sales we have red, right?
Okay, so sales is this one. Time this one get red. Okay. Focus one is orange. Focus one is fine. Focus 2 should be violet. Focus 2 was violet. That's focus 2 is violet. Focus 3 is yellow here. Focus 3 should become green. Automatic focus 3 should become green. And I think I made a mistake. So sales is this guy. Okay, so cumulative forecast is 4, which is red. But cumulative forecast should have this sky color. Okay, so this red should actually have this slightly sky color, not shade. Can't have this sky. It's not the forecast. The sales is this one. This should become red. Now let's compare. Sales is red here, sales is red here. Forecast 1 is orange, cumulative forecast 1 is orange, forecast 2 is violet, forecast 2 is violet, forecast 3 is green, forecast 3 is red, forecast 4 should have this sky color. Yeah. So I think this is correct.
Yeah, so let's put the two graphs next to each other. Right? So if you look at the forecast 4, look at the forecast 4. Forecast 4 is clearly showing that we're going to build up more inventory than what we require. If you compare the cumulative 4 graph, the cumulative forecast 4 graph, the cumulative graph,
Yes, sir.
the forecast 4, right? The forecast 4, if you compare with the sales, what is sales? Sales is red here. Red line and the blue line, they're having a huge gap. It means if you follow the forecast 4 model, if you follow the forecast 4 model, we're going to end up with higher inventory. Means there will be the inventory carrying cost will be higher. See, look at the graph, Sapna. It's a very important thing. See, we have done the forecast. Just mention the chart title and the second graph as forecast. Yes, Sapna?
Yes, Krish.
Yeah. So what you see in the forecast? Well, which one is the sales?
Sales is red one.
Okay. Now the sales is red one. Is it any modifications happened? Now we see a different mapping, right?
Yes, so that value of alpha changed. Right?
Okay, okay. Let's keep the alpha. Let's freeze the alpha. I think it's a good alpha, right? Let's freeze it.
All right, so
0.83.
0.
No, 0.83. It was 0.83.
0.8.
Okay. Now let's go there. Okay. Now by changing the alpha, what we are seeing here is that now we are seeing a very close map between all the forecast values.
Hmm.
Earlier it was point something. Can you make it 0.6 again? Back to 0.6.
Yes, I think the maximum difference was around 4, 5. So I'll just play around with a bit.
Yeah. Okay.
So 4, 5, yeah, the gap increased a
Gap
bit.
increased. So if you look at the blue line is sales. Red line is sales. Red line is sales. What we want is our forecast to be closer to the red line. Forecast period wise, the period wise means some of the 2 periods, some of the 3 periods, some of the 4 periods, some of the 5 periods should be equal to some of the 1 period of forecast, some of the 2 period of forecast, some of 3 period of forecast. That's what cumulative is. So the reason why I went to cumulative is, if you look at the forecast graph, the right hand side graph, the red lines, the red ones is the sales, and there are 3 or 4, there are four peaks are there. So what we are doing is with single exponential is we're getting a damping effect. What does damping effect does? What is the main role of dampening? Damping centralizes, right? Damping will actually create balance. We will not neither take the value to the peak or trough, or crest, or nor it will take to the trough. It will dampen, means it will try to create a balance between the top and the bottom. There is a main role of dampening effect. Leveling. Suppose if you have an uneven road, Can you drive on uneven road properly? Your bike will require a lot of maintenance if you drive on the uneven road. So what does the civil
Yes.
engineers does? Civil engineer will do the leveling of the road. Can they build a can they build a tar road on a unleveled surface? If they build a
No.
tar road on unleveled surface, tar will come out. They will not bind. That
Yes.
will not bind. So what does the civil engineer does? They do the leveling of the ground before they lay the tar roads. That's what we are doing here also. We are doing a leveling. That leveling process is we doing with the dampeners or the smoothing constants, which we have defined on the top point. I think at this moment is 0.45. So this is doing a dampening, up and down, up and down, up and down, and this is going to dampening. So the dampening is happening over for each and every model, whether it's forecast 1, 2, 3, 4, all the model are showing damping effect. But the damping, after doing a damping effect also, what we need to see is that the cumulative forecast should be close to each other. The cumulative forecast should be close to each other. So current with 0.45, can you do 0.35 there, the damping effect? So when you do the damping effect 0.35, see the gap is increasing. The gap for the forecast 4 is increasing. But if you look at the green one is what? Green one is forecast 3. The green one is forecast 3 and red one is,
Okay.
that is also
Red
having a,
one is
yeah,
sales.
so that's also having a gap. Now if you look at the blue one is what?
Forecast 4.
Forecast 2 or forecast 2, right? The forecast 2 is showing the closest map in the cumulative graph.
Okay.
Forecast 2 is showing the closest map with the sales. Forecast 2 and forecast 1, forecast 2, forecast 1 are showing the closest map in the cumulative graph.
Yeah. Hello, Krish.
Yeah.
There is some sound at my end. I'll just come be closing the door in a second.
Yeah. So the forecast 2 and forecast 1 are showing the closest map in the cumulative graph. But that idea is we are not getting in the forecast graph. Are you getting any idea in the forecast graph? Which one is the closest one? By just looking at the visual of the forecast graph, I'm not able to understand which one is the closest one. But when I look at the cumulative graph, I can understand which one is the closest one. One thing is very, very clear. The forecast 4 is not at all mapping with the current level of damping effect. So as we reduce our damping effect, forecast 4 is becoming non-value. As we decrease our damping effect, the forecast 4 is becoming non-value forecast. Can you reduce the damping effect to 0.25? Ananya, are you there? Hello, hello. Yeah, can we reduce the damping effect? Can we reduce damping effect from 0.4 to 0.45 to 0.25? Or 0.25? See, once we decrease the damping effect from 0.45 to 0.25, what we are seeing is the gap is increasing between the gaps are increasing. Right? So now let's increase the damping effect from 0.4 to 0.25 to 0.55.
Okay, so if it is 0.25, then we have this kind of a graph. Okay, so Krish, I'll just take a snapshot of this movie.
Yeah.
And this one was for 0.25, so 0.25 into C. It is based on the, if I keep it here, then